Welcome back. So in the previous video we discussed about the introduction of the cams. So in this video the continuation of the classification of followers. In the previous video we have been discussed about only the types. So in this video completely we are going to discuss about the classification of followers along with the graphical representations or along with the diagrams. We will be continuously going to be discussing about the classification of followers. So mainly as we know that it has been classified into three categories. First one is about according to the motion of the follower. So in that according to the motion of follower, further it has been classified into two categories. One is reciprocating or translating follower and oscillating or a rotating follower. So reciprocating or translating follower is when the follower reciprocates in guide and in it can able to guides it can able to rotates uniformly, then it is known as a reciprocating or a translating follower. So when the follower can able to reciprocate and in guides which can able to rotates uniformly, then it is or then we can consider that as a reciprocating or a translating follower. Oscillating or rotating follower is when the uniform or a rotary motion of the follower cam is converted into predetermined oscillatory motion of the follower, then it is called as an oscillating or a rotating follower. Say when the uniform rotary motion of the cam is converted into predetermined oscillatory. So whenever the uniform rotary motion of the cam is converted into predetermined oscillatory motion of the follower, then it is considered or we can able to consider that as an oscillating or a rotating follower. We'll see the diagram. See the reciprocating follower and an oscillating follower. You can able to see this is an a cam and this is an a follower and this is an a guideway which supports and fixed frame. We call it as a frame or it is a guide which supports the follower in order to transmit the motion. And this is an a camshaft where it will be fixed inside the cam. So whenever the cam is rotating, in irrespective of the direction, the follower has to pass the same direction. So here the oscillating follower. So the cam shaft and the cam, so you can able to see it is rotating in an oscillating direction. So whichever the direction the cam is rotating, the function of the follower is to follow that particular path or the particular direction only. That is about an reciprocating and an oscillating follower. So next one is according to the nature of contact. Further it has been classified into different categories. One is the knife edge follower. So when a contacting end of the follower has a sharp knife edge, it is called as a knife edge follower. So this cam follower mechanism rarely used because of excessive wear due to the small area of contact. In this follower, a considerable thrust exists between the follower and the guide. See, the knife edge follower is nothing but the edge of the follower will be in the contact with the cam. So the edge of the follower will be in the sharp edge. So the sharp end will be having in the edge of the edge in the is the sharp edge. So the sharp corner or sharp edge will be continuously contact with the this cam, rotating cam. So because of the sharp edge will be having whichever will be having in the contact, hence the contact area will be very small. Only at particular point the contact area will be there. Hence the excessive wear will takes place. So the applications of this knife edge follower is less comparing with the other type of followers. So the next one is about the flat faced surface. So when the contacting end of the follower is perfectly flat faced, so it is called as a flat faced follower. So you can able to see this the camshaft which is there. So the contact is only the flat faced. So between these two cam and a follower, the contact is only the flat faced. So mainly these are mostly this type of flat faced followers are used in automobiles. So next one is about the roller follower. You can able to see these are the different types of followers. We have seen knife edge and a flat face. This is the roller follower. So when the contacting end of the follower is in a roller, you can able to see this is a contacting like where in the previous we've been seeing the knife edge and then a flat face. So here when the contacting end of the follower is a roller, it is called as a roller follower. So here the wear of the cam is very less because the motion the contact between this roller and then a cam is will be in a rotational motion, hence so it will be continuously in the rotation motion itself only. So hence the wear of the follower and in between the wear of the cam and follower is very less because of its contact surfaces. Because of the contact surfaces only the wear is very less. So in the followers also the side thrust present between the follower and the guide, which is having a thrust present between the follower and the guide. Roller followers are commonly used within more space available, such as like a stationary large stationary gas or an oil engines and any aircraft engines. So the roller follower which is will be having a more space inside the engines or inside the components where we are going to use. So mainly we are going to use this type of roller followers. So because of this roller followers only, the contact between these aircraft engines will be very good in order to transmit the particular motion. So next one is about a spherical facet follower. So in the contacting end of the follower is of spherical shape, so it is called as a spherical facet follower. In the flat facet follower, high surface stresses will be produced. So in this flat facet follower, high surface stresses will be produced. To minimize the stresses, the follower will be having a spherical shape. You can able to see this. The shape of the follower is spherical. The major reason of making the spherical stresses is to reduce or to minimize the stresses, high stresses which are being produced in order during the machining surface or machining shape. So next one is nothing but according to the path of the motion of the follower. So mainly we have been seeing the according to the contact and according to the what type of motion it can able to produce. Now according to the path of the motion of the follower. So in which the path of the motion or in which the follower of the motion can able to be takes place. One is radial follower. So when the motion of the follower is along an axis passing through the center of the cam, that is known as a radial follower. And an offset follower is nothing but when the motion of the follower is along an axis away from the axis of the center, then it is called as an offset follower. So mainly the path of the follower is radial follower when the motion of the follower is along the axis passing through the center. You can able to see this. See, the radial follower is nothing but which whenever the follower is axis is passing through the camshaft, where you can able to we can able to see this. The shaft or an axis is directly contact with this camshaft axis. So that what when the motion of the follower is along the axis passing through the center of the cam, then it is known as a radial follower. Then what we call that this axis is passing through the center of the follower, then we call it as a radial follower. Similarly, if we take an offset follower, when the motion of the follower is along an axis away from the axis of the center, then we call it as an offset follower. You can able to see the difference. So the axis is now away from the center axis is away from the follower. So this type of follower, what we call it as an offset follower. The offset may be either towards the right or the offset might be towards the left of the axis. So this is what we can able to consider as a radial follower and an offset follower. So mainly the classification based on this types of followers is three: nature of contact, nature of motion, and the path of the motion. So these are all different types of followers mainly used in the different applications or an industrial purpose. So depends upon the application we want to select the type of followers. As we know that the function of the followers is to only to follow the path which is produced by the cam, so which can easily able to transmit the motion which is producing from the cams. So function of the follower is to follow the path of the cam only, right? So these followers has been mainly used depends upon application where we are going to use. So all the followers functions the same, but depends upon the application we are going to select the different types of follower in order to transmit the motion. Thank you.